Welcome back. This week we are going to talk about solving systems of equations by substitution, or the substitution method. And it's as simple as it sounds. All we have to do is substitute one thing in for another thing and solve for a variable. So take a minute to read through this. When you are done reading through this, you can continue the video and we'll go through 3 examples that will help you figure this out. The first one is a pretty straightforward example because if we look at this system of equations, we see x equals in the equation, or in one of the equations, and if we see x equals or y equals, that's a clear indication that we can use substitution to solve a system of equations. So what we're going to do is go ahead and substitute the y plus 2 into the top equation for the x. So we're going to take 2x plus y equals 10, and we're going to rewrite it as 2 times y plus 2 plus y equals 10. And by doing so, we eliminated the x, so now we only have y's in our equation, and we can then solve this equation for y. So we're going to distribute the 2, so we have 2y plus 4 plus y equals 10. And then we're going to combine like terms, so we have a 2y and a 1y, so that's 3y plus 4 equals 10. And then we can subtract 4, so we have 3y equals 6, and then when we divide by 3, y is equal to 2. Okay, so when we find y, we're halfway there because now we have to go back and find x, and to find x, we can plug that y into either one of the 2 original equations, and you'll notice that the top one is going to be more difficult than the bottom one, so let's go ahead and plug it into the bottom one. So we have x equals y plus 2, so we have x equals 2 plus 2, or 4. So our solution is the point 4, 2, and we always want to write our solution as a point. All right, in the second example, it's very similar. We see x equals, so we know that we can substitute for x in the second equation. So we're going to replace the x with 3 minus 2y. So we're going to go ahead and do that. So we have 4, and you'll notice each time I do this, I'm using parentheses, and parentheses are really important, especially when you have something like 3 minus 2y, because it is an expression that will require distribution once we substitute it. All right, so we have 4 times 3 minus 2y minus y equals 6. So the only thing that changes is that x becomes 3 minus 2y. So then we're going to go ahead and we're going to distribute here. So we have 12 minus 8y minus y equals 6. And then we need to do a little combining like terms. So we have 2 y terms. They're both negative. One's 8, one's 1. So we have 12 minus 9y equals 6. And then we're going to subtract 12 from both sides. So negative 9y equals negative 6. And then we're going to divide by negative 9. And you're going to notice this time we're going to get a fraction. So y is equal to, if I take negative 6 over 9, negative 9, that's positive 6 over 9. But then I can divide both of those by 3, so it ends up being 2/3. And I know a lot of you really like to grab the calculator and turn this into a decimal, 0.67. I would not do that because what you're introduced by doing that is rounding, and you're going to end up with a decimal for your y value, and we don't want that. So I'm going to circle that and put a line through it and say don't do decimals, keep it as a fraction, and we'll just use this fraction now to find x. Okay, so I'm going to plug it into the first one to find x, because the reason I choose the first one is because x is already by itself, and in the second one it's 4x minus y. So if it's 4x minus y, I'm going to have to do a bunch of work to figure out what x is, or to get x by itself. So in this case, I have x equals 3 minus 2y, and I'm going to plug in my 2/3. X equals 3 minus 2 times 2/3. And yeah, that's a fraction, and it's going to get a little tricky here, but I think we're perfectly capable of doing this. So we have x equals 3 minus 4/3. Because remember, when we multiply an integer by a fraction, we just multiply the numerator, we don't multiply the denominator. And so now we need to find a common denominator so we can combine these two together. So with a common denominator, remember this is 3 over 1, so we're going to multiply that denominator by 3. That means we have to multiply the numerator by 3, so we have x equals 9/3 minus 4/3. So 9 minus 4 is 5, so we have x is equal to 5/3. Okay, so there we go. We have an answer that's kind of unusual, because normally we're used to getting integers for our answers, but in this case we have two fractions. And fractions are completely fine because they are numbers. All right, one more example, the last one. If we look at this last one, it's not obvious that there's something we can substitute because we don't see an x equals or a y equals by itself. But if we look at that second equation, we can notice we have negative 3x plus y equals 6. We already have the y by itself. So all we have to do now is rearrange this equation a little bit so that we can get y by itself on the left-hand side. So to do so, we're just going to add 3x to both sides. And when we do that, we end up with y is equal to, now, if we were talking graphing, we would want to put that 3x first, but since we're doing substitution, you can write it either way. You could write it as 6 plus 3x, or you could write it as 3x plus 6. It doesn't matter. So I'm just going to write it like that. And now we have something we can substitute. So we have 6 plus 3x, and I'm going to replace the y in the top equation with that. So we have 7x minus 3 times 6 plus 3x equals negative 14. And again, you'll notice I use parentheses. Parentheses are super important here. And this one's a little bit tricky. You want to watch out for this because it's going to catch some of you. That's a negative 3 that we're going to distribute here. So we're distributing a negative 3. So we have 7x minus 18 minus 9x. If you're not careful and you distribute a positive 3, what'll probably happen is you'll have plus 9x instead of minus 9x, and that's going to throw you off quite a bit. All right, so we have some combining like terms. 7x minus 9x is negative 2x. We're going to add 18 to both sides. So we have negative 2x equals 4. And then when we divide by negative 2, we get x is equal to negative 2, because a positive divided by a negative is negative. All right, and then in this case, that x equals negative 2, we have now 3 choices. We can come back up here and plug that negative 2 into the first equation, the second one, or the one that we rearranged. And I'm going to suggest that we plug into the one that we rearranged right here, because the y is already by itself, and all we have to do is plug in that negative 2 and do a little simplifying. So I'm going to plug into that one, and so it's y equals 6 plus 3 times negative 2. So we have y equals 6 minus 6, or 0. Now some of you might be bothered by the fact that we got 0 for one of our x or y values, but it's totally fine. It's a number, so we can go ahead and have some confidence that it's negative 2, 0. And with all of these, you can check your work. You can plug both of these numbers back into both equations like we did in the very first lesson to determine whether or not that is indeed the solution.